If you spend enough time exploring Cold War bunkers, abandoned military outposts, and forgotten civil defense shelters, you start to notice a pattern. The modern world, with all its high-tech advances, often feels surprisingly fragile. We pour concrete faster, weld with precision, and model structural loads on computers that were unimaginable 60 years ago. And yet, some Cold War shelters, built decades ago, remain structurally sound, bone-dry, and thermally stable. Meanwhile, many modern bunkers, even those designed with stronger materials, fail within a few years. This stark contrast is not a coincidence. It comes down to a profound understanding of nature and time, an engineering philosophy that has been largely lost in contemporary construction. During the height of the Cold War, engineers faced a unique challenge. They weren't only preparing for bombs or radiation, they were designing structures that might sit unused for decades, potentially in harsh climates, and still remain functional. Their enemy was not just nuclear blasts or shock waves. It was the slow, relentless forces of nature: moisture seeping through soil, freeze-thaw cycles, pressure from shifting earth, condensation, corrosion, and material fatigue. Concrete cracks, steel corrodes, and soil constantly shifts. Without thoughtful design, even the strongest modern materials can fail over time. The secret to the longevity of these Cold War shelters was subtle yet powerful. They didn't try to fight nature, they worked with it. Instead of creating sealed capsules that trapped air and moisture, which is how many modern underground structures are built, Cold War engineers designed shelters to stabilize themselves passively. They used natural temperature differences in the earth, controlled airflow, and layered drainage systems to ensure that walls never had to combat environmental pressures. By controlling moisture, pressure, and temperature from the outset, the shelters avoided the slow, invisible decay that destroys other structures. One of the most important principles was pressure zoning. Moisture naturally moves from warm areas to cold, and from regions of high pressure to low pressure. Modern sealed bunkers often trap pressure imbalances, which draws moisture toward the structure and creates stress over time. Cold War engineers, however, built subtle pressure relief systems into the surrounding soil. They incorporated layers of gravel and stone, passive drainage channels, and venting paths that allowed the soil to communicate with the shelter. This prevented water from pressing against walls, eliminated condensation, and significantly reduced long-term stress on the structure. In Scandinavia, some of the most enduring Cold War shelters utilized a double-layered earth berm separated by coarse gravel. The gravel acted as a passive drainage layer, while the outer earth mass served as a thermal buffer, slowing freeze-thaw cycles. Concrete walls never expanded or contracted rapidly, and moisture was carried away before it could penetrate the structure. Decades later, these shelters remain perfectly dry, while newer bunkers, built without these layers, often suffer cracks, mold, and structural fatigue. This simple yet elegant technique demonstrates how understanding the movement of water and air in soil can extend a structure. S-life far beyond the expectations of modern engineering. Another overlooked element was ventilation. Modern shelters often depend on powered ventilation systems, which are prone to failure over time. Cold War shelters relied on passive ventilation shafts designed to work with natural convection. By placing one intake near the floor and one exhaust higher up, even a small temperature difference created a steady airflow. This airflow kept interiors dry, oxygenated, and free from condensation, preventing rust, rot, and mold. Even without electricity or active maintenance, these shelters maintained a healthy internal environment for decades. The concept of the earth lung is another masterful technique. Instead of compacting soil directly onto roofs, engineers layered gravel, sand, porous rock, or volcanic stone. This allowed the earth itself to breathe, slowly equalizing temperature and moisture without causing stress to the structure. The entire earth mound acted as a stabilizing system, cool in summer, warm in winter, and never allowing trapped moisture to become destructive. Modern builders can replicate this principle using permeable drainage mats or layered backfill, achieving long-lasting insulation and natural environmental control. Cold War engineers also understood that over-engineering walls was less effective than managing environmental stressors. Thick walls alone cannot prevent moisture damage, frost heaving, or internal condensation. Instead, by designing shelters to work with soil pressure, airflow, and thermal mass, the engineers achieved a level of longevity that modern structures rarely match. Their designs emphasized subtlety, using the laws of physics rather than brute force. Every layer of gravel, every vent, and every air channel was part of a carefully orchestrated system that balanced moisture, temperature, and pressure. The practical lessons of these shelters are remarkable for anyone building today. For root cellars, storm shelters, or earth-covered workshops, the same principles can be applied. Dig slightly wider trenches around walls, add angular gravel to create drainage, and allow moisture to escape naturally. Use passive ventilation shafts to maintain airflow, and consider layered earth coverings to stabilize temperature. These techniques prevent hydrostatic pressure from building up, reduce frost heaving, control condensation, and dramatically extend the lifespan of the structure, all without pumps, fans, or waterproof coatings. What makes Cold War shelters truly impressive is that they were designed with decades of abandonment in mind. Engineers anticipated that their structures might outlast human oversight, sitting dormant while the world changed above them. They relied on principles that did not require constant upkeep: passive stabilization, airflow management, moisture control, and intelligent use of the Earth's thermal properties. This is why many shelters today, despite being old, remain more durable than new constructions built with modern materials, but without the same attention to environmental design. The brilliance of these shelters teaches us an essential lesson. Longevity is not about overbuilding or using the newest materials. It's about working with natural forces, respecting the subtle movements of water, air, and earth, and designing systems that maintain themselves. By applying these principles, anyone building underground storage, emergency shelters, or earth-covered structures can create spaces that remain functional, dry, and safe for decades. The Cold War engineers mastered this philosophy, leaving behind a legacy of structures that survived, not by resisting nature, but by harmonizing with it. In essence, these shelters are more than just relics of a tense historical period. They are enduring lessons in engineering, foresight, and the quiet power of design that cooperates with nature. Every gravel layer, vent, and earth berm represents decades of careful observation, experimentation, and understanding. For modern builders, survivalists, or enthusiasts, studying these principles provides not just historical insight, but practical methods to create structures that truly stand the test of time.